Dear student, in this session let us discuss the important application of Chinese remainder theorem is to solve simultaneous linear congruences. Here I consider two simultaneous linear congruences. Observe here the coefficient of x is 1 in both the linear congruences. Suppose the coefficient of x is not 1, better to reduce the coefficient of x to unity by multiplying the inverse multiplicative inverse of mod. Okay, here the coefficient of x is unity. These two equations are ready to solve. For reference, I will call it as equation number 1 and 2. X is congruent to 2 mod 3. That implies 3 divides x minus 2. If it divides, there exists a third integer, say k. Okay, k is an integer. Let x minus 2 is equal to 3k, x becomes 3k plus 2. Here k is unknown. We have to determine the value of this unknown. X is equal to 3k plus 2 is a solution set to the equation 1. As we know that we are finding a root which is common to both the equation 1 and 2. Now x is equal to 3k plus 2 is a solution set to the equation 1. Now I am going to replace this x is equal to 3k plus 2 in equation 2. If I substitute the equation equation star to the equation number 2, okay, x is equal to 3k plus 2, replace here, you will get 3k plus 2 is congruent to 3 mod 5. Then 3k is equal to 3 minus 2 becomes 1 mod 5. Observe this congruence. The GCD of 3 and 5 is 1. By the property of congruence, if the GCD of A and M is 1, then the congruence has a unique solution. So therefore, we can find out by inspection method the value of k. That k satisfies this congruence. 3x is congruent to 1 mod 5. The 5 divides 3k minus 1. So by inspection, when k is equal to 0, you will get minus 1. 5 does not divides minus 1. If you replace k is 1, you will get 2. 5 does not divides 2. If k is equal to 2, k is equal to 2, 3 2s are 6, minus 1, 5. So 5 divides 5. Therefore, k is equal to 2 is a solution to this congruence. Therefore, put k is equal to 2 in equation the star. If k is equal to 2, you will get 3 2s are 6 plus 2 8. Therefore, x is congruent to 8 mod m1 and m2. m1 is from the first equation, this is 3, m2 is 5. The product of 3 and 5 is 15. Therefore, x is congruent to 8 mod 15 is a common solution to the given two linear congruences. Let us discuss one more problem. Again, I consider the two simultaneous linear congruences. X is congruent to 2 mod 5. Another one is 3x is congruent to 1 mod 8. Observe here in the first congruence, the coefficient of x is 1. So observe in the second congruence, the coefficient of x is not 1. So better to reduce this coefficient of x to 1 by multiplying the multiplicative inverse of 3 to the mod 8. Okay, multiplying the multiplicative inverse of 3 of mod 8. Okay, or you can take like this also. Consider this 3x is congruent to 1 mod 8. 8 divides 3x minus 1. By inspection method, the value of x is, if I replace 0 minus 0, you get minus 1. 8 does not divides minus 1. 1, you will get 2. 8 does not divides 2. If I replace 2, 3 2s are 6, minus 1, 5. 8 does not divides 5. If I replace x equals 3, 9 minus 1, 8. Therefore, 8 divides 8. Therefore, x is equal to 3 is the solution to this congruence. Therefore, x is congruent to 3 mod 8. So, 3x is congruent to 1 mod 8 is equivalent to x is congruent to 3 mod 8. These two congruences are same. Here this 3 is a multiplicative inverse of 3 under mod 8. Therefore, so we can write 3x is congruent to 1 mod 8 as x is congruent to 3 mod 8. Now consider this given first linear congruences as equation number 1 and reduced second linear congruences to x is congruent to 3 mod 8 as 2 for reference. Again x is congruent to 2 mod 5, 5 divides x minus 2. There exists a third integer, say k. So x minus 2 is equal to 5k. X becomes 5k plus 2. This is a solution set to the equation 1. We know that we are finding a root which is common to equation 1 and 2. So I can replace this x is equal to 5k plus 2 in equation 2. 5k plus 2 replace here in equation 2. So we'll get 5k plus 2 is congruent to 3 mod 8. Shift this 2 to this side, we'll get 1. 5k is congruent to 1 mod 8. Now this congruence has a unique solution because the GCD of 5 and 8 is 1. By inspection we can find out this 5k is congruent to 1 mod 8, that 8 divides 5k minus 1. So now by inspection k is equal to 5. 5 5s are 25 minus 1, that is 24. Previous 0, 1, 2, 3, 4 or not satisfies this relation. Therefore k is equal to 5 satisfies this relation. Therefore substitute k is equal to 5 in equation star. Here star is there. K is equal to 5. 5 5 is 25 plus 2 27. So x is equal to 27 satisfies the given two congruences. Okay. So now x is equal to 27 mod 40. So that is m1 and m2, product of m1 and m2. So here m1 is in the first equation is what? M1 is in the first equation is 5 and m2 is 8. So m1 is 5 and m2 is 8. The product of 8 and 5 is 40. Therefore x is congruent to 27 mod 40 is a unique and common solution to the given two congruences. Thank you.